Okay, so we have this integral here, and this is actually a problem I've been avoiding for a little while. I mean, not that long. I've probably been avoiding this for a few days. The reason I've been avoiding it, at first it looked pretty tedious. I just didn't want to do it. And when I did it the first time, it wasn't too bad, but it was still a little tedious and not that exciting. But then I did it a second time and noticed there's a pretty good shortcut, and then I thought it was worth doing a video on it. Okay, so let's get to it. So what I did to start was I just took this and factored this as a difference of two squares, just noticing we could write this as x squared plus 4 times x squared minus 4. But what I want to do instead of the formal partial fractions is let's just use this denominator, and let's take our x squared plus 4. Let's see what happens if we subtract x squared minus 4. Well, if we do that, our x squared terms are going to cancel. Minus minus is plus, and we're just going to have an 8 here. And that's actually not too bad, because what I can do is let's rewrite this same denominator, and then let's subtract those terms up here in the numerator. So we'll have x squared plus 4 minus x squared minus 4, just knowing that this is 8. Now, of course, we've changed the whole integral, but what I can do is just multiply by 1 over 8. Now we're back to our numerator just being 1. We haven't changed it, so we're fine. And then what we can do from here is we can split this into two integrals. Okay, so all I've done here is just rewritten it and split it into two. But the beauty of this, we get a cancellation here, so we'll just have a 1 on top. And then here, this will cancel with this term, and so we just have a 1 on top there. Okay, so now that we've cleaned this up, we notice that we just have quadratics here in the denominator now, and this is going to be easier to deal with than what we started with the fourth power. And actually, these are both well-known integrals, so we can use a formula. Let's just take a look at the formulas now. Okay, so we have two very similar formulas over here on the right. Just noticing, okay, this is our formula when there's a plus sign, so this is our first one here, and then here's the minus sign for this one here. And the difference, we get a minus sign here, and we have our first formula is going to be arctan, and this one is going to be inverse hyperbolic tangent. So we'll go ahead and use this formula. I'm actually just going to bring a 1/8 out front. So then for this first one, we'll use this formula here. So we're going to have minus 1 over. Now for our a value, this is, in both cases, it's going to be, we can write this as 2 squared, and we can write this as 2 squared. So in both cases, our a is going to be 2. So here in this first formula, we're going to have 1/2 tangent inverse x over 2. For the second one, I'm still going to have a minus sign. I factored out the 1/8, but I'm still going to have a minus sign here. But then this is going to be, our a value is 2, so we're going to have 1/2 arctan x over 2, well, plus c. And I think I'll just factor minus 1/2 out of these just to make it nice. So let's just do that real quick. So for our final solution, we're going to have, multiplying minus 1/2 times 1/8, we're going to have minus 1 over 16. We'll have our tangent, and then we'll have our arctan x over 2. Oh man, I didn't leave enough room for my plus c. Here, let's make some room for a plus c. And we'll do the skinniest plus c ever. And then I'll just do the skinniest plus c in the history of plus c's. And that's it. So even though this started out as what I thought was a boring problem, I think it was pretty fun. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.